Good morning, children. See, already we are discussing about different methods of refining the ore. We discussed three methods in our yesterday's class. What are the three methods? One is the distillation, second one is the liquefaction, the third one is the polling. Okay. Next, today we will discuss another important method of refining the metals, that is electrolytic refining. What is that? Electrolytic refining. Electrolytic refining. See, in the name itself, electrolytic. Electro means we are using electricity. Okay. Next one, at the same time we are using an electrolyte. Electrolyte is, what is that? Any solution which we are using to send the electricity is nothing but, from which we are sending the electricity is nothing but electrolyte. Okay. So, electrolytic refining. We are refining the crude metal. Are you clear? So, electrolytic refining. So, refining the crude metal to get the pure metal by sending electricity is nothing but electrolytic refining. Where from you are sending the electricity? You are sending the electricity from the salt solution, that is metal solution. You are sending electricity through the metal solution. Are you clear about that one? Now, for this one, what are the materials needed? First thing, you take the case of copper refining. We follow this technique to refine the crude metal copper. Now, for that one, you need the concerned metal solution or salt solution. This is copper sulfate solution. Next one, two electrodes. Two electrodes. Here, these two electrodes, one electrode which is connected to the positive terminal of the battery is considered as anode. What is that? Anode. So, we are taking impure metal or what is that? Crude metal. What is that? Crude metal. So, crude metal is taken as the anode. Crude metal is taken as the anode. Next one, a strip of pure metal. Strip of pure copper metal is taken as cathode. See this one. See, we got the crude metal in our previous stages. That crude metal is taken as the anode and a fine strip of pure copper metal is taken as a cathode. Okay. Next one, concerned salt solution or metal solution is taken as electrolyte in the pot. Are you clear? So, this entire solution is known as what we call it? Electrolytic bath. What we call it? Electrolytic bath. Where current passes through the solution. When current passes through the copper sulfate solution, what happens at anode? See this one. At anode, copper loses 2 electrons. These electrons are at anode only, remember that. Next one, this copper ion moves in the solution, because it is the copper ion, it always moves toward the cathode. Are you clear? Cathode is the negative terminal, negative plate. So this copper ion always moves toward the cathode. Are you clear? Next one, there at the cathode, this copper ion receives 2 electrons and deposited as pure copper metal. Pure copper metal is deposited on the cathode. Are you clear about that one? Now you may get the doubt where from the electrons came. Already I told you there are 2 electrons, that 2 electrons are released. Okay, are you clear about that one? Next one, this copper ion moves, at the same time the electrons are also moving in the circuit. Observe this one. The electrons are moving, they reach the cathode. Are you clear? At the cathode, those 2 electrons are received by copper ion and pure copper metal is deposited on the cathode. So there you got the pure metal. Are you clear? So here in this process, what we are doing, we are taking the electrolyte of the concerned metals. Okay, so salt solution or metal solution, copper sulfate. For example, if you want to purify magnesium, you have to take magnesium chloride or magnesium sulfate as the electrolyte. Are you clear about that one? So you have to remember one thing, the cathode and anode belongs to both metals, that is same metal. Okay, you are refining the copper, means cathode is copper and anode is copper. The only difference is anode is impure one, crude metal, whereas the cathode is a fine strip of pure copper. Are you clear? When current passes, these are the reactions that are taking place at anode and at cathode. So there at the cathode, copper is deposited as a layer. Are you clear? Next one, another important thing you have to remember. Next, soluble impurities dissolves in the electrolyte and insoluble impurities are collected at the bottom of the anode. This is known as anode mud. What is that? Anode mud. What is anode mud? Anode mud is the insoluble impurities that are present in the impure metal. It is deposited at the bottom of the part near the anode. That mud is known as, what we call it, those impurities are known as anode mud. Are you clear? This is known as, what we call it, electrolytic refining. No need to by heart anything. Electro means you are sending electricity. Electrolyte means where the electrolysis, in which solution the electrolysis process is taking place. Next one, refining. Refining means you are purifying. You are purifying or you are getting the pure metal from the impure or the crude metal by sending electricity through the salt solution or the metal solution. Are you clear? Do you understand the concept? Next one, instead of copper sulfate solution, if you take some magnesium chloride solution, what happens? Because when if you have taken magnesium chloride, try to understand, why can't we take magnesium chloride instead of copper sulfate? They may put the question like this. If you take magnesium chloride or any other metal solution, what happens? It decomposes. Magnesium Mg plus 2Cl minus. Are you clear? But this magnesium ion is deposited again on the cathode now. Try to understand. You want to get the pure copper metal. That's why you have to take copper sulfate solution only as the electrolyte. Okay, none other than copper sulfate solution is not taken as the electrolyte. This is the reason. Okay, if you take any other metal solution, that metal also deposited on the cathode along with this copper. Are you clear? But you need only copper now. Try to understand the concept. Okay, this is the reason why we are taking the copper sulfate solution only or concerned metal solution only as the electrolyte. Okay, And clear, this method is known as what we call it electrolytic refining. Okay, make a note of. We discussed how to refine copper, crude metal copper, by a process known as electrolytic refining. Are you clear? So as you know that in periodic table you studied, all the metals are electropositive in nature. Most of the metals are electropositive in nature, means they always tries to lose the electrons. They always tries to lose the electrons and become positively charged ions. Are you clear about that one? Next, non-metals. You take the case of non-metals. They always tries to gain the electrons. They always tries to gain the electron and become negatively charged ion. Are you clear about that one? So, because of the nature of electropositive nature of the metals, they always tries to lose the electrons. Okay, whenever those metals, okay, few metals, whenever they are exposed to atmospheric oxygen and moisture, atmospheric oxygen or water vapor and moisture, okay, atmosphere in the sense it is a mixture of several gases, okay. Air is present, means when we are talking about air, means in air oxygen is present, several other gases also present, along with that moisture is also present. Okay, by the action of this atmospheric air and water vapor or moisture, the metal surfaces are eaten up. The metal surfaces are eaten up. This phenomena is known as what we call it corrosion. What we call it? Corrosion. Okay. So, what is corrosion? Eatening of metal surfaces. Eatening of metal surfaces by the action of atmospheric air and moisture is known as corrosion. For example, you take the case of this iron. See this one. A brown reddish layer is formed. Observe this one. A brown reddish layer is formed. Actually, iron metal is not like this. Why there is a layer? This one is exposed to the atmosphere, air and water vapor. Are you clear? So that atmospheric oxygen and water vapor reacted with this metal surface. Are you clear? So when it reacted with the metal surface, a metal oxide, a layer of metal oxide is formed on the surface. This metal oxide is nothing but rust. What we call it? Rust. In the case of iron, it is known as rust. Next one, you take the case of, this is copper, metal copper. This vessel is made up of copper. Okay, it is exposed for atmospheric air and moisture for several days. You will find, see this one, bluish green layer is formed. Are you clear? Copper is not like this. Are you clear? Because it is exposed to atmospheric air and moisture, a layer of greenish blue color is formed. Metal carbonate is formed here. This is nothing but, this greenish blue layer is nothing but copper carbonate. In the atmosphere, carbon dioxide is also present. That carbon dioxide reacted with this metal. Okay, copper carbonate is formed. A layer of copper carbonate is formed. In the case of, you take the case of silver. You girls, you wear the ornaments. Okay, silver ornaments. If you observe the silver ornaments, after few days or few years, you will find black color. Okay, black color in the silver ornaments. Tarnishing of silver ornaments. We call it as the tarnishing of silver ornaments. Okay, black layer is formed. What is that black layer? That black layer is nothing but metal sulfide. What is that? Metal sulfide. In the atmosphere, sulfur dioxide gas is also present. That sulfur dioxide gas reacted with silver. Okay, silver sulfide layer is formed on the metal. So that is known as tarnishing of silver metal. So all these processes are known as what we call it? Corrosion. Corrosion is a oxidation process. Remember that it is a oxidation process. So what is meant by corrosion? Corrosion is eatening of metal surfaces by the action of air and moisture called corrosion. A layer of metal oxide is formed on the metal surface. You take the case of iron. It reacted with air and moisture. You will get iron oxide, that is Fe2O3 NH2O. N stands for number of molecules of water vapor. Okay, so this is known as what we call it rust. This is known as rust. Are you clear? This is known as what we call it rust. This entire phenomena is known as corrosion, whereas in the case of iron, this is known as what we call it rusting. It is known as rusting. Metal oxide layer, that is iron oxide layer, is formed on the iron surface. This phenomena is known as rusting. Okay. Next, come to the case of silver. In the case of silver, a layer of silver sulfide is formed. This phenomena is known as what we call it tarnishing. This is known as tarnishing. In the case of silver and copper also. You take the case of copper. You will find bluish green layer. So because of carbon dioxide present in the atmosphere, it reacted with copper surface. Okay, copper metal surface, and a layer of copper carbonate is formed. What is that? Copper carbonate. What is that? Copper carbonate is formed. On the metal surface. Okay. So corrosion, all these are considered as corrosion. Examples for corrosion. Okay. In the case of iron, corrosion is known as what we call it rusting. Are you clear? See, just now I told you, this is nothing but rust. A reddish brown layer is nothing but rust. Are you clear? Fe2O3 NH2O. Number of water molecules, you don't know how many. Okay, maybe 2 or maybe 3 depending on the moisture. Okay, next one. Here in the case of this one, see this one, this is a copper vessel. In the case of copper, see this one. What is that color? Bluish green. This is nothing but copper carbonate, because of the atmospheric carbon dioxide reacted with the metal surface. In the case of silver, you will find a black layer. That is silver sulfide. Are you clear? This entire phenomena is known as corrosion. Okay. In the case of iron, it is known as the rusting, and in the case of silver, it is known as tarnishing. Are you clear about that one? So I told you what is corrosion and what is meant by rusting and what is meant by tarnishing. Are you clear? So how can we protect the metal surfaces from rusting? For example, in the case of iron. For example, see this one. Actually, this is a test tube holder. This is also rusted. But I applied a paint. Okay, applying the paint protects the metal in coming contact with the atmospheric air and moisture. Do you understand? So when you painted a metal surface, see, atmosphere, water vapor and oxygen first reacts with the paint. So metal surface is protected, na? Do you understand the concept? Next, applying the oil, greasing. Okay, next, electroplating. Okay, galvanization. Okay, making alloys. These are all the different ways to protect the metals from tarnishing or rusting or corrosion. Are you clear? So I told you in this session, how to refine the metal like copper, what is meant by electrolytic refining. Next, how can we protect the metals, okay, metal surfaces from rusting and corrosion. Are you clear? Thank you.